Y'all doing? All right, I'm glad 3 of you are good. That makes me happy. How y'all doing? All right, there we go. I'm so excited you're here. We started early. It's not even time yet, but we did it because we're excited. My name is Eric Johnson, and I'm super happy to be here. I'm a principal developer advocate at AWS. And we're going to slip our slide on here real quick. There we go. All right, now we're seeing what we should see. And Matt, introduce yourself.
Hey everybody, my name is Matt. I'm part of the specialist team here at AWS. I'm a container specialist. I spend most of my time helping customers build cool, exciting, interesting architectures with ECS and Lambda and all of our cool app mod technologies.
I have to be honest, I'm super thrilled to talk with Matt. Matt and I have got to travel a lot together. I have now learned to say his last name properly. It's Mekis, not Meeks. At least that's what he tells me.
Almost.
I nailed it, didn't I? Yeah, so how many of y'all have heard me speak before? Oh, a good room. Okay, do you know the rules? All right, a couple of you know the rules. Mark out here knows the rules. All right. Well, for those of you who don't know the rules, do you know the rules?
I don't know the rules, Eric.
Okay, well, here's the rules. So when I'm speaking, rules is probably a strong word, but it'll really help you kind of as we go through today because I like to have a lot of fun. But these are the rules, all right? There's 3 of them. Okay, the first is, this is any number I want it to be. Okay, now I'm going to hold this up and I'm going to say there's 3 rules. Okay, and someone who comes in late is going to be like, that's not a 3. Well, it is because that's the rule, right? Okay, the second is these are quotes, not apostrophes, and I know that. Okay, because this looks dumb. Okay, so I do this, right? And finally, these are thumbs, because this will get you beat up. All right? So those are the 3 rules, and that helps a lot. I do like to make a lot of one-finger jokes. I will make jokes as we're going through today. I'm very comfortable. I was born this way. I didn't wake up this way for the first time this morning. I did wake up this way, but not for the first time this morning. But again, I'm very comfortable with that. However, if that makes you uncomfortable, I'm also comfortable with that. So I'm good, and we'll have a good time today. Super happy you're here. Matt and I have been working through this, excited about this deck. How many of y'all are using, by the way, if you're not familiar with y'all, that's everybody in the room, so that's a Texas thing, so there you go. Or there's all y'all too. So how many of y'all are using ECS now? Oh, okay, all righty, good. How many of y'all are doing event-driven architectures with ECS? Well, why are you here? All right, so you want to learn how to do it better? Okay, we gotta meet the bar. Yeah, exactly. All right, there's a lot of pressure on us to hit this. So that's what we're going to be talking about today is event-driven architectures, but using Amazon ECS with AWS Fargate. And that may not be the first thing you think about. You may not go, yeah, EDA, we think Fargate, we think ECS. But it's a very viable solution, and today we're going to talk through that. All right, you ready?
Let's go.
Here we go. All right, we want to introduce you to a buddy of ours. This is Sarah. Now, I know we've all been, let me ask you this, how many of y'all are developers? Okay, how many of y'all dabble with code but don't claim to be a developer? All right, so you're a developer. Stop hinging on that, all right? So if you dabble with code, you're a developer, right? This is Sarah. Sarah runs a mid-sized development team, right? And they use ECS. They primarily use ECS, and they love ECS, and they love Sarah, right? And here we are, and we've all been there. This time it's November 27th. Do we have the dates right? That might be wrong. Did I change that? We'll see. Anyway, it's Black Friday. Maybe I have the dates wrong. We'll see on that. But it's Black Friday. It's late in the evening. Anybody been watching their architecture right before Black Friday? If you haven't been a developer long, right? I've been that developer in the middle of the night, and you're watching, you're good, you're solid, things are looking okay. Maybe there's a little hiccup, but we're okay. And then all of a sudden, 10 minutes later, everything falls apart. Right? 10 minutes after you drop a brand new SKU, something exciting is coming out, your system can't handle it. And this is where Sarah's at. And we've all been there at 3:30 in the morning. If you haven't had your head on a desk crying, you're not a developer. Right? Or put your head through a wall, right? So we've all been there. But here's the truth, okay? This isn't an ECS problem. It's an architectural problem. Right? If you don't know who that is, that's me. So, I don't, or Matt. It really could be Matt too. It's just the beard that makes the difference, right? So what went wrong? If you think about this, what went wrong? Well, like so many people, when Sarah built her architecture, she built it using synchronous microservices. Now, microservices are a good thing, right? We hear that all the time. Microservices, small, independent services that run together. We love that. But the synchronous part can kind of get us into trouble. And why is that? Well, when we make that order, we hit the discount, and everything's good. The next thing we're going to do is we're going to check our loyalty, and oh no, our loyalty blew up. So what happens is the whole thing kind of fizzles and falls apart. Because we've tightly coupled this architecture, and it's all kind of dependent on each other. And this probably isn't news to a lot of you, right? You're like, oh, yeah, I've seen this before. But you might have some architecture this way. Anybody responsible for that old 1988 code that's built like this, right? I've been there, right? And so it's like, well, how do we fix this, right? So in reality, Sarah needs a different way. So when we say a different way, let's look at the synchronous model and see kind of why we want to change that. So when you think about synchronous response and request models or request response models, you think, well, these are good, right? They've got some advantages. They're low latency. They're very fast, right? It's simple. Yeah, anybody can build a synchronous microservice, right? And it fails fast. It's very often, or it's not very often that we like to fail, but when we're going to fail, we want it to fail fast and we want it to fail in development, right? So that's a good thing. But there are some pretty big disadvantages to this as well. Ones that are worth probably looking at getting out of it. So, right? The first is we can get throttling, right? And so when you build these out, your producer, it needs to know about your consumers, and as it's going through, it gets complex. It can get throttled because it can't send everything, or maybe your consumer gets throttled because it can't handle everything. And then you get resiliency issues, and you have problems on Black Friday at 3:30 in the morning. And that's where you're at. So how do you fix that? Well, that's what we're going to talk about today, and we're going to talk about that in relation to running microservices and running things on ECS. Now, how do we think you should do this? Well, really, and this is going to be a little oversimplified, but it really comes down to not using synchronous microservices, right? It comes down to what we like to do is insert a broker of some type. Right, where we want to say, rather than in that previous model where the producer talked to the consumer and the consumer responds to the producer, instead, we're going to put a broker in. Now, this broker is a very kind of just a term we're using. I'm not picking a specific one. We'll actually get into that in a little bit. But this is the idea of something's in the middle, and their entire job is to go, hey, I got your request. Have a good day. And then the consumer, either through pulling, or pushing, or any different kind of models, will say, hey, give me that, or hey, thank you for that, and I'll acknowledge. And maybe they acknowledge to the broker, maybe they acknowledge back to the client. There's different patterns. We'll look at that. But this idea of having something in the middle to help break these apart and decouple the producer from the consumer is where we get into a lot more flexibility and reliability. All right? So we're talking about this idea in what we call event-driven architecture. Now, let's look at what does event-driven architecture mean. I'm going to read this to you. Event-driven architecture, EDA, is a distributed computing paradigm implementing asynchronous message passing semantics through intermediary message brokers, enabling temporal and spatial decoupling of system components via non-blocking I/O operations and persistent event storage. You can go. I've given you all you need to know. Anybody understand that? I intentionally had Claude give me a complex explanation, because sometimes EDA is a mystery to us. We look at it and go, oh, that's scary stuff. But in reality, I'm going to give you a more technical definition of EDA. And if you were ever going to write something down or take a picture, this is the time, because this is going to get super technical. I might have to do it a couple times. So let me explain EDA to you. You ready? Matt still doesn't understand this, but I'll get it to you. All right?
I'm getting that, Larry.
Okay, yeah. All right, so here's a less technical, but it's still a technical definition of EDA. Something happens, and we respond. We react. I got it wrong. We're going to do it again. Did everybody get that? Let's try it again. Something happens, and we react. That's EDA. Yes, that's oversimplified, and yes, it's a little tongue-in-cheek, but it's the idea of, rather than our consumers going, what are you doing, what are you doing, what are you doing, what are you doing, what are you doing? Or our producers going, here's what I'm doing, 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 and the logic getting very coupled, we're able to say, let's break that apart and make them kind of decoupled from each other. So what does that look like? Well, here before EDA, we have this producer who's talking to the consumers, and the producer needs to know about each of these consumers. Needs to know, hey, who's consuming my data, and so it needs to send to each one. So if something happens, it's going to send to the consumer 1, send to consumer 2, send to consumer 3. We kind of saw this pattern already. So let's throw in a broker, some kind of broker, and we break this down and we say, okay, now instead, I'm going to just send out an event, and I don't care what happens after that. I mean, overall and metaphorically and allegorically, I don't even know the right words, we care, but the producer doesn't care. It just says, hey, I did my job, here's an event, whoever consumes it, do it. So these consumers go, okay, yeah, I want that, I want that, I want that. And so there's some benefits to this. When we build this out and we say, okay, we're going to break these apart, it gives us the ability to build very scalable applications. Right? And so we're able to build bigger because we're not so tightly coupled. It also gives us resilience. Right? So if consumer A goes down, consumer B is still chugging along. If there's some dependency on each other, we can handle that, but they can handle that gracefully. We can degrade gracefully. Right? And finally, it gives us a lot of agility. When you build this way, rather than constantly updating that producer to send it to, you need to know more logic to talk to these consumers, we need to then, all we do is we add another consumer and say, I'll consume that as well. So we can do that unbeknownst, that was a big word, that was almost a British word right there. Unbeknownst to the producer, we can do that, right? This is a really cool pattern. However, here's the catch. Like so many of you, Sarah's asking a question, how do we go from synchronous microservices to event-driven architecture? And that's why we're here today, right? So I'm going to turn it over to my buddy Matt, and Matt's going to walk you through some of this, and we'll be talking about some things.
So I think this is often when someone like me gets involved. So you've got a customer who's had a major problem. They want to make some sort of transformation or modernization, and we've got to think about what's the kind of mental model we're going to use to go through this journey from kind of monolithic synchronous services to EDA. I like to think of 3 real buckets of kind of categories of questions we want to think about. First, we've got our business logic, so the actual stuff that we care about as developers, the stuff we've wrote. We've got to run that somewhere, so we've got to think about what's our compute. Eric talked about event routers, and he just put a kind of a nice green circle in his diagram and said, hey, we've now decoupled. There's a lot more subtlety to that, so we've really got to think about what event routers are we going to use, what are the trade-offs, what are the patterns that we can apply. And then we've got to take those components and we've got to combine them into all of these architectural patterns and blueprints that we want to do at scale, because whilst something happens, we react to it, is really, really simple on that side. Actually, there's a lot of subtlety. Actually, within the category of event-driven architectures, there's a whole bunch of quite precise sub-patterns we can use that have their own trade-offs and complexities. And we want to kind of codify those so we can use them at scale across our organization, baking best practice into what we do. So first off, we've got some options around compute. And I think that one of the really common things that I see customers do when they come out of a big outage and your CTO is grumpy, hey, we built this modern microservices thing, we're running it on ECS, and we still went down. They kind of throw the baby out with the bathwater. We're going to throw all this away, and we're going to refactor to Lambda, because we've seen that Lambda is scalable, and Lambda always, AWS takes care of it, and we don't have to think about it. Lambda's great at scaling, but you can still, with bad architectural patterns, get yourself caught into some dead ends. Or let's throw away this ECS thing. If we move to Kubernetes and the Kubernetes ecosystem, maybe we can solve all of our problems with this technology change, and that's going to be more scalable, more powerful. Look at all these cool open source things that we can buy, and we can use this whole ISV ecosystem. Well, actually, I'd like to propose that when you're going through a big architectural change, you want to really focus on the bits where you can add value, and you probably don't want to change everything at once. If you're changing programming language, don't change architectural pattern. If you're changing architectural pattern, maybe don't change your compute. So limit yourself to the sort of a set of things that you can change. And also, we want to go on an incremental journey. We don't want to say, hey, we're going to spend the next year building a brand new platform that's going to be ready in early November, so when Black Friday comes around, we can throw a big switch and go to anything. We want to make a series of changes. Every week, we're iterating towards this path over the next year, so when our next big sale comes on, we're all ready. So my hypothesis is, let's go and do this. Let's stay on ECS, and let's see how we can build this with ECS, because we're going to make a whole bunch of other interesting changes. A little bit of info about what ECS is. I think we got a lot of hands raised in the room, so I won't belabor the point too much, but I think it's a pretty cool service run by AWS that allows you to deploy, run, launch containers at scale, does a whole bunch of optimizations behind the scenes for you, so you can focus on delivering business value. And customers tend to agree, so something like 3 billion Amazon ECS tasks are launched every week, which is just like a completely wild number. A really interesting one that I really like is that when people start building with containers, the majority of them start building with ECS. So it's a really, really common pattern. When you're using the ECS control plane, there's a couple of options with your data plane. You could use Fargate, our kind of serverless data plane, where you just define your tasks and your services, and we'll manage that compute for you. We have a isolated workload model where you get kind of strong tenancy, and you only pay for the compute that you're using. However, we're making some choices and on your behalf. We think they're sensible choices, but they're not the right choices in every case. You can also bring your own data plane. So you can say, I want these specific instance types in this size, and I'm going to manage scaling them out, and Fargate is going to go and run them on those EC2 instances. One of the big pre-event releases a couple of weeks ago was ECS managed instances. I'll do another little poll in the room. Who's seen the ECS managed instances release in the last few weeks? Has anyone heard of it? Yeah, a few hands, but it's pretty early still. ECS managed instances and the Lambda managed instances that was launched last night are really, really interesting models where you can bring your own data plane of EC2 instances, but AWS does all the management of those instances on your behalf. So we'll do all the patching, OS patching, management of those instances. You can just define what instance types you want to use. And so you get a lot of the benefits of using that kind of flexibility that I want a specific Graviton instance in my fleet because I've worked out my Java code runs best on those instances. But you don't have all of that overhead. It's also got a really interesting modification to the capacity provider that means it scales faster than running your own EC2 instance fleet, which is really, really cool. So that moves the shared responsibility a little bit. So instead of having to think about your own auto-scaling and launch templates and availability, distribution and instance selection, you can hand it over to AWS. You can define the instances that you want in your task templates, and we'll take care of it. And you can get all the benefits of your savings plans and all the kind of capacity planning, et cetera. However, it doesn't mean that Fargate isn't still the kind of default way that people are building on ECS. And I think that most people should probably start with the most serverless option, which is Fargate, and only break out if they've got more complex requirements. So we've chosen ECS. We're going to continue running on Fargate. We think that's still a sensible option. There are a couple of different models when you're running with ECS. The first thing is running with a standalone task. So with a standalone task, something happens. We get a run a task event. And the Fargate service goes, OK, great, something's happened, let's react. So we're going to go and provision some compute to deal with that event. And we're going to take some time provisioning, so we'll go through a provisioning state. We're then going to go and run that task. So we're going to do some running. And then afterwards, we're going to get that container and we're going to throw it away, stop it, and not reuse it. Now, that's a really, really good pattern, really powerful. But it is newing up a container to run each of your events. So it's not really appropriate if you're sending thousands of events. We're trying to do a Black Friday sale. We've got 1,000 orders a second coming into our e-commerce store. We don't want to be using this model for that. It's going to get us into some trouble. We also have this other model where we can run as a service. So this is, we can define some compute. So we're going to say we want a vCPU, we want a couple of gigs of RAM, we want to have at least 4 copies, and we want to scale that out with some scale parameters. And Eric's going to talk about some of the metrics you can use to scale out later. And so we're going to go and build a target group that's going to be running, and actually we can think about how we can send events to that kind of statically stable compute and how it's going to scale out, and Eric will go into some more details around that. So we've got these kind of big patterns, and my hypothesis is these are really powerful, really useful characteristics to use when we're building EDA. We've got scalability, we can have kind of target tracking, we can build all sorts of interesting target tracking with custom metrics. Containers and microservices and these kind of patterns are very comfortable together. And because it's an AWS managed service, it has native integrations with all of the building blocks we use to build event-driven architectures. Things like step functions, Event Bridge, even SQS and SNS, all play very, very nicely with Event Bridge. And you can use all of those things like managed instances and savings plans and Spot to make sure that you're getting the best price for your compute and the best total cost of ownership. So settled on some compute. Our next big category of questions is what event brokers are we going to use? What routers are we going to use? And so our first category of brokers are routers. Routers are a pattern where the router processes one event at a time. You can point that event at multiple targets and protocols, so it's a one-to-many pattern. You're building logic at the router, so you can build rules and filtering rules and targets at the router. So you've got quite a smart, sophisticated router that's doing a whole bunch of work for you, and that means that the router can handle things like retries, dead letter queues, error handling, even things like throttling and rate limiting. So it's a pretty smart router, which means that it's really simple to have simple logic at your receiver and your sender. So for your receiver, a single SDK call, your receiver just has to either pull an event through a native integration or a simple API call. So you don't have to build a lot of error handling and additional logic in your producers and consumers. And so that allows you to really, really efficiently reduce coupling. In the Amazon world, we're usually talking about Event Bridge when we're talking about this pattern. So it's a serverless service, has native integrations with most of the things on AWS, allows you to build global architectures with global endpoints. And so the Event Bridge architecture starts with defining some event sources. So that could be an AWS service, your custom events, in our case, a lot of custom events. Those then go to a number of buses, so a default event bus, a custom event bus, depending on whether it's an AWS event or your own event. And then we have these rules. So a rule is the way that we then map those events into the downstream services. So the first thing I'm going to do is define what is an event. So this is one of the things that we have to be really deliberate about when we're building event-driven architectures. So we go sort of one step deeper than something happens and we react. Something happens in the past. So we emit a signal that state has changed. So an order has been created, an order was created, or a channel was created, or the lights switched off. We can't change it, so we can't unswitch off the lights. We have to submit a new event that says, hey, lights are switched on. And these events act as this contract between our producers and our consumers. In Event Bridge world, that's a piece of JSON. And an Event Bridge rule is pretty simple. So we've got a bit of JSON, which is our event. That's our producer has emitted that event. And our rule has another bit of JSON, which says, hey, our source is com.flix, our region is Australia and New Zealand, and we want to get all of those events and pass them to a particular consumer. They've matched, that's great. And so those consumers can be a whole bunch of different patterns. So we can point to Lambda, and lots of event-driven architectures are built with Lambda, but we can also send that to Amazon ECS, as we discussed earlier. You can also talk to API destinations, and that's a really, really powerful feature of Event Bridge, and Eric's going to go into some detail around the nuances of that shortly, and a whole bunch of other services. However, this is not the only pattern we've got for event routers. We've also got topics. Topics are a subtly different form of event router. Here we can broadcast to multiple consumers. We still can filter consumers at the topic. However, this is really powerful for scaling out to lots and lots of consumers. We can support multiple protocols, things like SNS, SMS, push notifications. We also have options to maintain order with first in, first out topics. And so fully managed service for doing this in AWS is SNS. It allows you to send nearly unlimited messages per second, and it says that in our documentation, nearly unlimited, and so we're kind of serious about it. It's very, very difficult to put any strain on the SNS service, and you can send out to 12.5 million subscriptions on each individual topic. So if you've got a fan out and you want to send codes or messages to everybody, that's really, really powerful. So we talked about routers. Our next kind of category of things are event stores. So an event store allows our receiver to process events in batches and control how it's doing processing. So it can control its order, it can configure its own retry, it can configure its own dead letter queue. Now, one of the important things about a queue is only one receiver can process a message. So it's a one-to-one integration rather than a one-to-many integration. You can manage that ordering, but it's typically not used as the backbone of our event-driven architecture because of that one-to-one pattern. It's used more as just kind of some of the sub-patterns we're gonna think about. In AWS, the main service for doing that is SQS. It's another one where the docs say we scale nearly infinitely, super easy to use, simple API, dead letter queues, first in, first out, all the kind of features we expect. We also support some of the open source services, so things like Amazon MQ, which supports RabbitMQ or ActiveMQ. So if you're using some kind of integration with existing open source stuff, definitely a sensible option and supports many of the same patterns that you'd be using. And then the third and final big bucket of brokers we can think about are streams. So streams are subtly different again. Here we can do one-to-many, so we can send messages to multiple consumers. However, all the consumers that are reading a stream are going to get all the messages. So the consumer itself has to manage the filtering. You've got ordering enforced in the stream, but again, the consumers have to manage their own kind of error handling and processing to ensure that ordering is enforced. Really, really powerful service, particularly if you're doing really, really large throughput of messages. And so we've got Amazon Kinesis as an AWS native version of dealing with streams. You could do gigabits per second of streaming, all the kind of integrations that we talked about with native integrations. And the big player in the open source space here is MSK or is Kafka. So Apache Kafka, absolutely huge project, really, really powerful streaming solution, which has loads of open source integrations and used for lots of event-driven architectures. Our managed service for that is MSK, so you can use all the kind of Kafka goodness and get lots of the management done by AWS. So we've now got this kind of box of toolkits. We've got some compute, we've got some routers, we've got all these kind of services, and really, really easy to start putting some of those services into our diagrams and starting building things with these things, particularly where you just set up an event bridge bus, a few lines of code, a few lines of SAM or CDK or Terraform, and you can be up and running. But they're actually, they're very, very powerful. There's a lot of places you can go wrong. So the kind of the meat of what we want to do is how do we turn all these Lego bricks, all of these different building blocks into useful things that we can build? So Eric, I think you're going to talk to us about some of the patterns we can apply.
All right. So we've talked to you about, what is EDA? What are obviously all and for those of you here in America, routers is routers. So just throw that out there. I know some of you are like, well, I don't even know what a router is, but it's a router. So I got you. Yeah, I got you. So, all right. So we're going to talk about what are these patterns? How do we apply this to ECS? How do we make that work, right? So let's jump in. And we're going to talk about long-running containers, right? And this is kind of those services that Matt was talking about earlier. And so this is like, it's a push or pull. It's kind of an end-to-end, right? Is how many do you want to send? How many do you want to process, okay? So a traditional long-running container looks something like this, right? You have an ECS, you get many different type of tasks with different containers running in that. You know, a lot of ECS users in there. I don't really need to probably teach you about that. And of course, you have your capacity providers with our new, again, the managed instance, which is super cool. You can do a lot with that. So I want to show you, we're going to go through some different patterns. And the first pattern is probably the most simple, right? And this is a very common pattern. Pattern number one is the public API. Now what this usually is you're going to have some type of consumer or producer pushing data to a consumer, right? And it's going to go through an API. So it's somewhere, another machine, they've got a signed URL, or they've got something, and they're pushing to this data. But your consumer, even though you run this container, maybe it doesn't, again, we have that 1988 code and it's not ready to handle all that. So how do we put a broker in something like this? Well, EventBridge is where I generally start. This is a really good way to say, events coming in, and I'm going to send those, and then I'll push them on to the container through the API. And how that works is the producer is going to send directly into the EventBridge using IAM, that's a hard one. IAM roles, it has permissions to do that. It's going to push data into the EventBridge, and EventBridge is going to use this API destination to make a secure connection to the API and drop data into, or drop events into that the consumer, and it can run however many we need to. And we can kind of control that through EventBridge on how many are we sending, different things like that. Now, you may say, Eric, that's great, but not all of us are doing machine to machine, right? What if it's clients? That's all right, I got you. So you can actually do something like this, where you can say, okay, I'm going to have an authenticated user send data to API Gateway. Let's say they're sending, I don't know, analytics or something like that. And then I'm going to use, anybody familiar with VTL? Okay, do you love it? Yeah, I know exactly. He's like, I want to tackle you for saying it. So VTL is Apache Velocity Templating Language, and it runs that API gateway, and you can actually transform a request come from a user and put it right onto EventBridge. And I've got some examples out in the wild of how to do that. But this allows you a secure access where they can continue to push that, and I don't have to run a Lambda function in between, and I can still get data to the container. So this is pattern number one.
And writing VTL is no fun at all, if anyone's tried it, but Kiro is really good at writing VTL code.
Oh, yeah.
A couple of prompts and you'll have something working really, really quickly.
Yeah, VTL is back because of Kiro, and it's velocity templating language, by the way. I'm just proud I know that, so there you go. All right, so the second pattern looks a whole lot like the first because it really is. Right, and so what we're doing here is we have this ability in EventBridge and we announced this last year with Private Link and VPC Lattice, you can actually connect to private endpoints, right? So this is super helpful if you have to, look, I need to throttle how much is getting in there, so let's go ahead and drop data into EventBridge, and then we'll use the private endpoint connection, and now we've done that. So those are the first two patterns, again, kind of starting easy, and we'll climb up there, right? So the next pattern we're going to do is what we call point-to-point, right? And so this looks pretty simple, but what we're doing here is we have ECS containers that pull for events. So instead of things getting pushed to the ECS container, it's going to actually pull data off the queue, and so you manage the rate limit in the code. You can say grab 10, grab 20, but you can also do some of that, the window and control on SQS as well. And your retry and failure are managed at the queue as well. So if something doesn't happen, you get a retry out of that. And so this gives you a lot of control and downstream protection, right? Now, when you're running queues of polling patterns, it looks kind of like this. It'll basically take, let's say you have 6. So I'll grab 6 off there, and my different tasks will handle that, kind of like Matt was showing how the queues work on that. And then, so how SQS works, if you're not familiar, is when a task is grabbed, it doesn't actually disappear out of the queue. It's made invisible. It's magic. It's the invisible queue, or invisible event. And after a certain amount of time, if the consumer hasn't said, yep, I took care of it, then it's made visible again and it can be redone, right? So this works really well when you have, your traffic's metered and you can do that. However, what if your traffic is unpredictable, right? It's like, I get a lot of traffic and then I get a little bit of traffic and then I get a lot of traffic and it goes up and down like that. Well, that's all right. We can handle things like that through what we call predefined metrics or through autoscaling, right? So with autoscaling, we're actually able to do step scaling on SQS using the message count. So we look at the message count and how do we step that up to handle the autoscaling and how do we bring it back down. In this particular example, I'm doing +1 task at 5 messages, +2 at 15. So it's watching that, and it's going up as need be, and it's coming down. And then we put in a cooldown of 300 seconds, so we don't, what you don't want is your autoscaling doing this, right? You want it doing this. How relaxing was that? That was cool. All right. I feel good. All right. So you want to do that. So that's why we put in that cooldown, and then you get multi-period evaluation. So we're looking over, we're not just looking at one and reacting, one and reacting, one and reacting. It's looking, okay, how's the scope look? Right? So this works really well for a lot of your traffic. So you use these predefined metrics, and there you go. However, not all traffic is the same size, the same shape. Traffic looks very different, right? I don't know about y'all, but you never know. Am I processing a 2-minute video? Am I processing a 2-day video? Those kinds of things. So what if this looks really big and your size is not consistent? How do you do that? Are these predefined metrics going to work? Probably not. So then we get into custom metric math. Now, I've never been great at math, I'm not going to lie. I can only count to 2. All right, some of you are awake. I can actually, here's the truth, I can get to 4 if I take my shoes off, but that gets weird for everybody. So we'll go with 2, right? So the idea here is we're going to use custom metric math, and we're going to combine some metrics, right? So we're going to do metric messages divided by the running tasks. We look at the pack log per task. And we're going to go for a target value of acceptable latency divided by processing time. Right? So we're looking at some different things, and then we set this up. We still do our cooldown, so we're not reacting really fast, and and we prevent division. You can see I've got some code in there by doing a max function, so you prevent division by 0. And so this allows us to do some mathematical equations. I'm saying all kinds of big words. Some math to figure out how we're going to do it, but not just one metric. We're using multiple metrics to do this. And so this is an idea of how that policy would look and how you set that up.
Well done, Eric. I've been
Thank you.
watching Eric rehearse that for the last 2 weeks and trying to get his maths out. So
I can't do math to save my life. Like, I can't. I don't know how to do this. So Matt's been tense up till that moment. So, all right, thanks, buddy. All right, so that's how you do that. So when you're going to do metrics, don't just let your system run and go, oh, I sure hope it makes it, right? You have the story, you have the observability to go, okay, we can follow that. And that's really important anytime you're doing anything, but really specific in EDA, because you can build really optimized systems that work, that run with your load rather than just saying, all right, provision till we can handle anything and pay for that, right? Okay. So the next thing we're going to get into are what I call event-based containers. Now, I haven't made that a popular term yet, but every reInvent for the last 2 reInvents I've said this. Someday it's going to stick. I'm coining this. Mark, I want to see it in a blog. So, all right. So, event-based containers. So what I mean by this, it's kind of like event-driven containers, but a little different. And maybe I'll explain that, and maybe I'll forget. But it's this idea of a one-to-one, right? So, and Matt explained it earlier. When we want to run one container for an event. So what does that look like? Well, so we got a producer, and we're going to kick an event into EventBridge. Now, normally if I'm running a container on Fargate, I will have a service, and that service will have a task definition. This will all be at the container level. But now with this, I can actually do the task definition at EventBridge. That actually will come with the event. I can say, hey, here's a definition, here's an event, do your thing. Right? Now, I'm not going to get any data back. I'm just going to get a simple, it's basically a fire and forget. But that works for a lot of what we're doing, right? So your producer is going to kick a single event out. That EventBridge is going to take that. It's going to send the task to, it calls the run task API, and it's going to run that. And you get one task versus to one event. And actually, it's not necessarily one container. You want to look at it. It could be multiple containers because you might have multiple tasks, sidecars, things like that. All right? So this is the pattern 4. This is the EventBridge pattern. This is very popular. And this is really hidden. You don't want to use this for dump 1 million events into EventBridge and bring up 1 million containers. That's not how, the run task API will get overrun. It's not designed for that. You want to do this, we actually built this exact example here a couple of years ago. We were doing video processing in serverless because it can be done. And we were running video processing, and we would say, okay, if the video has these maybe file size or time limit, because we had the metadata. If it's under 2 minutes, process it in a Lambda file, because that's all we need. If it's over 2 minutes, spin up a container. Most of our videos were under 2 minutes, but every once in a while we had those one-offs, right? So this is a really good example on doing that. We can do rules for that to set it up. All right, so the second one looks somewhat like this. Pattern 5 is step functions. Who uses step functions today? Oh, do I love step functions. I'm a step functions nerd. I believe step functions first, and I'm super excited about it. So step functions can work much like Event Bridge, in that it can actually have the task definition, and you send that to Event Bridge. But it gives you a little bit more flexibility. It gives you synchronous, and asynchronous options. Now, that means blocking and non-blocking, right? So, let me show you how this can work, okay? So, the async pattern, this is the first one we're going to do, and this is kind of a fire and forget just like Event Bridge. So what we do is we use a run task, and so it's an async, it's a fire and forget, and it returns an acknowledgement of the request. Yes, I got your request, I'm working on it. Move on. And the step function will actually move on from this point, it won't wait. You don't get any data back, off you go. However, sometimes there are times when you need to stop and wait. You need to know that that was successful or failed. So we also offer what we call the .sync pattern. This is kind of cool, not kind of, it's really cool, because it handles the polling for you, right? So what happens is when it sends to the run task API, and then it polls the describe ECS task for a status. If it worked, then you get a 200 back. If it failed, then you get a 400 or a 500 or whatever going on, right? And so, however, you still don't get data back from the ECS. And a lot of times this is okay. But this is if I need to poll services, and this happens a lot, okay? But you may say, Eric, yeah, we need data back. How do I do that? Well, let me show you. So, next pattern we're going to talk about this is the callback pattern using the token and send task completion. Anybody use this now? All right, a couple of you, okay. Anybody like, wow? Well, I haven't explained it yet. Let's wait on that question. All right, I will get a wow out of you. All right, so the way this works is when you come to this task, it's going to generate a token. And it's going to send that token with the data and the task definition to the run task API, and it's going to bring the task up, right? And then it's going to give all that data to the container, and the container will churn out, and it'll sit and wait. And it'll wait for that task to be done. So in the container, when the job's all done, you actually call the service. There's an API endpoint, send success or send fail, and you call it with the callback token. And step functions goes, oh, I know which workflow that is based on your token. Here you go, success or fail, and here's the return data. Okay, so you're able to get data back to the step function and modify and work on that later. So this is a very, very powerful event-driven model that you can do in step functions, right? Okay, so then the task needs to invoke step functions, and the API goes to complete, and off you go. Now, there's one more pattern I want to show you that I'm going to be really honest, I just learned about last year, and I think is super cool. And I think you just learned about it.
I learned about this in practicing when you talked about it a few months ago, Eric. So,
is anybody using activities in step functions? Okay. Anybody heard of activities in step functions? Okay, one person, but he knows VTL too, so he's kind of a nerd. All right, so let me tell you about activities. So here's how activities work. When you go into the console, you can do it through the API, but you actually create an activity outside your step function. It sits on its own. So you create this activity, and what happens is step functions creates a managed SQS queue. And it's going to manage it for you and handle all that stuff, right? So then what you do is from your step functions, and not just one of them, but any of them. You can pump data into that, or pump events into this activity queue. And then you have a pool of ECS workers. Yeah, we're tying ECS in here. This pool of workers then, much like any other pattern we've seen, pulls for this data, does the work, it's got the same kind of interaction as SQS, because it's an SQS queue, and then sends back to step functions with the task token and the data. And now you've sent, you're handling tons. This is when I have thousands upon thousands upon thousands of events, and I need them to be processed from multiple workflows. This is the pattern for this. Now, we talked about this last year in this very session, actually. And I will tell you, this stuff really works. Don't just take my word for it. This tweet came out in September. It says, a few months back, inspired by a great session by EDJ Geek. That's all I wanted to read. No, I'm just kidding. Let's go on. We made changes to an AWS step function, reducing its cost from $450 per invocation to $1. If you're intrigued, check it out, and I'll post that in the resources. And you can find it. Now, the first question is, oh my gosh, what are they doing that costs $450 per invocation? Right? But they were doing a lot of work, a lot of transitions, hundreds and hundreds and hundreds and hundreds of like minuscule micro transitions that probably made more sense to run in an ECS cluster. Right? So this activities pattern handled that for them. All right, so activities gives you several benefits. First of all, you manage queue, you get a 1-year retention of that. Second, connects to on-premise. This is where, oh, hey, I need to process this with on-premise stuff. You can do that from there. And finally, loosely coupled architecture and flexibility to use Spot, which is, a lot of people don't think about this, but if I'm using clustered ECS, I can use Spot for that. All right, so let's talk about how does this help Sarah. Sarah was in trouble. Let's show her.
So now we've got a whole set of tools that we can combine with our ECS architecture. We've got all of our different brokers that we can apply. We've got all of these different patterns that we can apply to our architecture. So what does that actually look like? We talked before, we are a relatively sensibly designed microservices architecture, containerized. The first thing we can do is start publishing some events. So we've got our order service. Every time an order is created, we can go into create an order created event. We can make a single SDK call. That's going to publish it to EventBridge. We now want to go and do something with that event. So maybe we want to take out our payment service that is currently happening synchronously, but depends on some third-party APIs. We want to go and make that asynchronous. So we accept the transaction. We do some validation on the payment details. We assume that our payment processor is going to process it. And if there's a problem down the road, we can actually go and send the customer a message and say, hey, can you come and retry with some new payment details? We can do that with our existing service by having a rule that's got that API integration. We can do a private API integration into our VPC using all the stuff that Eric showed. So pretty quickly, we can take two synchronous services and break them up using a really, really simple pattern and make them asynchronous. We also want to go and send a bunch of messages to our customers. So instead of having a direct SDK call to one of the messaging services inside our code, maybe doing it synchronously, we can break that out. So we'll have a separate rule that's looking at those orders and sending you an SMS message saying, hey, your order's been confirmed, or actually you need to go and update your payment details. We've got our loyalty service. So a year ago, this is the service that blew up. We've got a third-party service that we were expecting to respond immediately. Now, it's important that our customers receive loyalty points when they make a purchase, but it probably doesn't have to happen immediately as part of that flow. In fact, we're probably happy if it happens some point before the end of the month. Here we can send all of those orders and the order details into a queue, and that loyalty service can process them on their own time. We don't need to scale out that service. It can just trug away and make sure it's kind of catching up with that queue. And then finally, we've got this really cool activity pattern that Eric taught us about. Once a month, we want to go and run a process that's going to look at all of our customers' sales and loyalty points and tier changes and do a whole bunch of processing and go and send them some personalized discounts to help them, encourage them to come back and buy some more stuff. So here we can use step functions and activity pattern, and we can actually do that batch processing in a really, really efficient, event-driven way. So we can keep applying these patterns in different ways to our architecture. So Event Bridge at the heart of it, using ECS for our compute, and quite quickly get to a new solution. So next year in November, when things ramp up, Sarah sits at a desk and nothing happens, and boss is happy, everyone gets to celebrate. Oh, Sarah, we're happy for you.
That's right. So Sarah's happy. She's now EDA, partially, and she's moved part of it. She's a good part of it, and she can do a lot more. So here's what I want to help you with when you walk away from here. If you're not doing EDA now, it's not a flip of a switch, right? I love this statement. Werner Vogels, VP and CTO at Amazon, says, systems that don't evolve will die. He's also the one that says everything breaks all the time, right? Two very well-known quotes. So it's important that we evolve. If your system is good enough, it probably won't be soon. You always want to be watching, even if it's working, is it working efficiently? Is it saving you money? So one thing we encourage when you're looking on your EDA journey is, where do you start? Well, you may not have full understanding. It's EDA, like anything else, you learn as you go. So I encourage you to start small, start with an implementation that you can start working on, and your understanding will grow with that. Obviously, don't start in production. Just hopefully you know that already, but there it is. But as you grow with that, you learn more and you go. So here's some key takeaways I would give you. Synchronous microservices crack under pressure. You learn that. Sarah didn't fail because of ECS. She failed because of the tight coupling, things like that. EDA is the ultimate decoupling superpower. It really is. It allows you to really build that scale and reliability. ECS plus Fargate brings the muscle. Serverless containers, 0 servers to manage, instance scale, things like that. And you've got routing options for days. This can give you a lot of flexibility to do that. ECS runs every EDA pattern like a champ, right? So we talked about push, pull, sync, async, callbacks. Autoscaling becomes your superpower. ECS managed instances equals less hops, so you're gonna be able to, obviously we talked about the managed instances, how those are gonna help. And step functions unlock next level orchestration. So you're able to do a lot of orchestration on that. And finally, loosely coupled systems. And yes, Sarah does win by running this route. We promise you some resources. I encourage you to check these out. S12D.com, CNS307-25. All right, here's a couple other resources I'm going to give you here. Let me go back. I saw some of you still trying to get that, so let me throw that up here for a moment. All right. And then the next thing I'll tell you is we've got a couple other resources I would encourage you to check out. I tried to get ones after this, but the best practices for service developers, super strong session. This is a great one. API 207 using event-driven architectures to modernize legacy, more EDA. And then Serverless Espresso is a great example of event-driven application at scale. Get the coffee in the expo hall or the certification lounge, and then go see how it was built. I really encourage you to do that. If you want to learn more about serverless and application integration resources, we have a lot out there. On behalf of Matt and myself, I really want to tell you thank you. Matt, you have anything else you want to throw out? Shameless plugs?
If you can make it to the Mandalay Bay at 5:30, we'll be doing a chalk talk, diving into a lot of these patterns in more detail and really helping unpick them with the audience. I think that's the last one.
All right. And for my shameless plug is on Wednesday. I'll be discussing at 10:30. And I can't mention what that is right now, but I encourage you to keep 10:30 Mandalay Bay open. If you love serverless, you'll love me for this. So that's all I can say. I wish I could say more, but I encourage you to do that. With that, I want to say thank you very much. Please fill out the survey. Let us know. We always like to know how we can do better. Enjoy reInvent. Thank you very much.